Somewhere out there is a planet the color of coal. Not painted, not shadowed. Black, because it swallows almost every photon that touches it. We found it in 2011. We haven't found anything darker since. Let's be precise about this. TRES-2b reflects less than 1% of the light that hits it. Coal reflects more. Fresh asphalt reflects more. This world absorbs 99% of everything that arrives and gives almost nothing back. At first, that sounds like a curiosity. A strange rock, far away, none of your business. Except it isn't a rock. TRES-2b is a gas giant, roughly Jupiter's size, orbiting so close to its star that it should be glowing, reflecting heat and light like a lantern hung too near a fire. It doesn't glow. It disappears. Here's what that actually means. Something in its atmosphere, a vaporized sodium, potassium, compounds we still can't fully name, is eating the light, not blocking it, consuming it. The planet sits for million miles from its sun, baked to nearly 1,000 degrees, and instead of shining, it goes dark. Astronomers have a phrase for this. They call it a black planet. They don't like saying it out loud. And TRES-2b is not the strangest thing we've found. Let's go further out. 59 light-years away, there's a planet twice the size of Earth. Rocky, dense, familiar. Almost, until you look at the numbers. 55 Conchorei orbits its star so tightly that a year there lasts 18 hours. The dayside temperature climbs past 4,000 degrees Fahrenheit. Hot enough to melt iron. Hot enough that the surface, if you could call it that, is likely an ocean of molten rock. But here's the problem. Its density is wrong. Too light for solid iron and stone. Too heavy for gas. Something is missing from the equation and the leading model to fill. The gap involves carbon. A lot of carbon, compressed under pressure, at temperature, for billions of years. Compressed carbon has a name. Scientists have proposed, cautiously, that a third of 55 Conchorei mass could be crystallized carbon, diamond, not a vein of it, not a deposit. A planet where diamond may be structural, load-bearing, buried under graphite and silicate crust, glowing under heat no human instrument has ever touched directly. A diamond world you could never land on. A diamond world that would kill you in seconds if you tried. And still, this isn't the one that should worry you most. 90 light-years from Earth sits a planet named HD 189,733b. From a distance, through the right filter, it looks almost peaceful, deep, saturated blue. The kind of blue you'd associate with an ocean or a clear sky on a calm day. It is neither. The blue comes from silicate, particles suspended in its upper atmosphere, the raw material of glass, shattered into microscopic shards and blasted through the sky. Let's be precise about what that means. This planet has winds measured at over 5,400 miles per hour, 7 times the speed of sound. And embedded in those winds is glass, not falling gently, moving sideways, horizontally, at hypersonic speed, in a storm that never ends, on a planet that never stops facing its star on one side and never stops facing eternal night on the other. There is no morning on HD 189,733b. There is no dusk. There is only the line between permanent day and permanent dark, and the glass storm that circles the entire world, forever, in that boundary. We gave it a soft name, a pretty color. It is, by any honest measure, one of the most violent places we've ever detected. And then something happened that made all of this feel almost gentle by comparison. In 1992, astronomers found the first confirmed planets outside our solar system, not orbiting a star like our sun, orbiting a pulsar. A pulsar is what's left after a massive star dies. A stellar corpse, city-sized, spinning hundreds of times per second, screaming radiation into space in a beam that sweeps the sky like a lighthouse, built from a nuclear detonation. PS RB1 to 57 plus 12 has at least 3 planets locked in orbit around it. Think about what that requires. These worlds likely formed after the star that birthed them had already died, condensed from the wreckage of a supernova, coalescing in the graveyard the explosion left behind. They are bathed, continuously, in radiation levels that would strip an unshielded human's DNA apart in minutes. Not once, not in a burst, constantly, every second, since the moment they formed. No atmosphere could survive it. No surface water. No shielding thick enough on a small rocky world to make the radiation survivable. We don't know why life couldn't exist there. We know, with near certainty, that it can't. And that raises a question most people don't want to sit with. If planets can form in the wreckage of a star's death, bathed in lethal radiation, orbiting a corpse that used to be a sun, then planet formation isn't fragile. It isn't rare. It isn't something that only happens under gentle, hospitable conditions. It happens in hell, too. Here's what that actually means. The universe is not selectively building worlds for life. It's building worlds, periody indifferent to whether anything could ever survive on them. Diamond planets, glass storms, black worlds that eat light, pulsar, graveyards where 3 planets orbit a dead star's screaming radiation belt. We are the exception, not the rule. Every disturbing planet we catalog is more evidence of that. Let's be precise about the last one, because it's the one that should stay with you longest. WASP-76b sits 640 light-years away, tidally locked, like HD 189,733 BA, one face burning, one face frozen. No rotation to ever balance the two. On the day side, temperatures reach nearly 4,350 degrees Fahrenheit, hot enough to vaporize metal. Iron doesn't sit in the ground there. It rises into the atmosphere as gas. Then the planet's rotation, slow, locked, eternal, carries that iron vapor toward the terminator, the line between day and night. And there, in the cooling dark, it condenses. It rains iron, not metaphorically. Astronomers detected the spectral signature directly. Iron vapor present on the day side, absent on the night side, consistent with condensation and fallout. At the boundary between permanent fire and permanent cold, molten metal, falling like water forever on a world that never sees a sunset end. We've named these places. We've measured their winds, their temperatures, their compositions. We talk about them the way we'd talk about anything cataloged and understood. But understanding a place and surviving it are not the same thing. Every one of these worlds formed the same way ours did. Gravity, gas, collision, time. The same physics, the same universal rules that built. Earth built a planet that rains glass at 7 times the speed of sound. There was no guarantee, anywhere in that process, that the result would be livable. We got lucky. Or we got specific, the right distance, the right star, the right chemistry. In a universe that produces black planets and diamond planets and iron rain far more easily than it produces us. Somewhere out there, right now, glass is falling sideways through hypersonic wind. Iron is raining into permanent night. A planet is refusing to reflect its own star's light back into space. None of them know we're watching. None of them would care if they did.